Hey A&Pers, this is Dr. Jones checking in. This is A&P 1, Lecture Test 1, video, checks notes 6. We did page 8 for video 5, and now we're doing page 9 for video 6. Page 9. Okay, so this is the homeostasis lecture. Homeostasis is the basic concept of how your body keeps you alive. So, very important. This is a word that never goes away. Okay. Some words that we only use in 2401 and we don't really use in 2402. Yeah, this is not one of those words. Okay. Homeostasis is the maintenance of a relatively stable internal environment. So, it's your body keeping your blood sugar level steady, your blood calcium level steady, your temperature steady, all of the signs, everything you can measure, this is your body keeping it steady, or within a normal range. We'll talk about that. Homeostatic regulation are the ways to maintain homeostasis. And there are a number of homeostatic regulations, and we're not going to talk about all of them. A receptor is the sensor of stimuli or environmental changes. Let's go through the boxes and then we'll discuss. The control center is the information processing. The control center receives the information, makes a decision, in air quotes, and gives commands. The effector is cause and effect. The effector is a cell or organ that responds to the commands. It makes changes on orders from the control center. And then the set point is your desired value or range. And this is negative feedback where you negate the original stimulus to minimize the change. Okay, so let's explain all of that. So using the example of the air conditioner, homeostasis will be normal room temperature. The stimulus will be, let's say you left the blinds open when you went to work and the sun is beating into your house. So let the winter sun in, keep the summer sun out. And because the blinds are open and the sun is shining in, the room temperature rises because it is summer in Texas and that happens. The receptor in this case is the thermometer. And that information is sent to the control center, which in this example is the thermostat. And once it's hot enough, it sends the command, it makes a decision, in air quotes, and sends the command to the effector, which in this case is the air conditioner, turning it on. And then that blows cold air. So the room response here is that the room temperature drops back to our normal room temperature, which is homeostasis. So we draw this as a sine wave where when it gets too hot, here's our set point, which they have at 22 degrees Celsius. My house, we tend to do about 75 degrees Fahrenheit, although that's never right at 75, is it? Because when it gets up too high here, then the AC turns on. And when the AC turns on, that makes the temperature go back down. Once it gets below normal, that turns the AC off. And then as the sun comes back in, it goes back up again. So this is the sine wave of life. And this normal range here, in medical speak, we put as WNL, all caps. And what does that stand for? Those of you who work in healthcare may know that this means within normal limits. So when you set the temperature at 75 degrees Fahrenheit or 22 degrees Celsius, whatever it is you set your temperature at, how often is it right at that temperature? Not very. It's usually a little above or below, right? So this is the normal range. Anytime you get blood work back, it doesn't say that this blood level should be this number. It says this blood level should be within this range, and anything within that range is considered normal, within normal limits. So normal is, I go with the meme, you know, the kid asks, Mama, what's normal? And Mama says, it's just a setting on the dryer, honey. That's it. Although I gotta say, we had to get a new washer dryer after Harvey, and there's not a normal. There's like a bunch of settings. It's fun, lots of stuff it does, but normal is not one of them. So, all right. So, why is homeostasis important? It keeps you alive. In the example of the home thermostat, what's the receptor? Thermometer. What's the control center? Thermostat. The E factor, air conditioner. And how do they work together? When it's too hot, the AC comes on, and that makes the temperature go down. So that's what they mean by negative feedback. Whatever is wrong, you negate it. You do the opposite. So too hot, make it get cold. What if it's too cold? Then you turn the AC off and you let it get warm again. You do the opposite. So my house, we bought a year before Harvey, has the fancy one where you can have the air and the heat on at the same time. So if it gets too cold, you can actually turn the heat on and make it warmer. And then when it gets too warm, it'll turn the air on and make it colder. Generally, I find if that's happening, then it's better and cheaper just to open all the windows. So, but that's me. So when room temperature rises, and the stimulus is this change away from normal, away from homeostasis, negative feedback's response is to make it go down. So it's too far up, you make it go down. Too far down, you make it go up. And this will be the same in any negative feedback situation. Okay, I turn the slide. Okay, there we go. Okay, so it works similarly in the brain for your temperature regulation. So, hello. Okay. So for you, homeostasis is normal body temperature. The stimulus is your body temperature rises. Maybe you're outside in summer. The receptors here are the temperature centers in your skin and in your hypothalamus, which is inside your brain. And that affects the control center, which is in your brain. And that makes a decision, as it were, and sends a command to the E effectors. So when you're too hot, your sweat glands start sweating, and that causes evaporation, which cools you off, which is a response. Body temperature drops, it takes you back to homeostasis. Also, the blood vessels in the skin dilate, and that allows you to literally radiate heat off of your skin. So that's pretty cool. So it'd be like if you're cold, let's go cold first. If you're too cold and you say, well, I'm going to put this sweater on. Okay, sweater on because I was too cold. Except now I'm too hot, so now I'm gonna take the sweater off. And then I'm gonna get too cold and, and get cranky about having to put the sweater off and on. If you haven't had class at Del Mar, the lab room tends to be about 10 degrees hotter than the lecture room, maybe 15. I haven't actually measured it, but often need a sleeveless shirt in one building and a sweater in the other building. So negative feedback. If you get too cold, warm yourself up. You get too warm, cool yourself off. And this keeps you within your normal range. And so this is negative feedback, which is doing the opposite of whatever's wrong. So this will work for all of your blood systems. We talked about all of your systems. We've talked about temperature, but if your blood calcium level was too low, the negative feedback response would be to raise it. If your blood calcium level was too high, your negative feedback response would be to lower it. If your blood sugar level were too low, you would raise it. If your blood sugar level were too high, you would lower it. Most of your body systems use negative feedback as their homeostatic regulation. There are a few systems that use positive feedback. Next slide. There we go. Positive feedback amplifies the original stimulus. Now, could we do that with temperature? What if we got too hot and the body said, make it hotter? Oh, too hot? Make it even hotter. Your brain would burn out. Literally. Like, you can do that. What if you got too cold and your body's response was to make it colder? You'd have hypothermia. So anytime you're outside of WNL, when you're a little bit out, you'll have dis-ease, too hot or too cold, or too low a blood sugar, or too high a blood sugar. And if it continues, then you lose the joke and you're straight into disease, some sort of disease state. So there's WNL, and it's the same outside the other direction, dis-ease and then disease. So positive feedback is only used in a few body systems because in most they would cause problems. When you have a positive feedback, it tends to cause a positive feedback loop, which is the tendency of positive feedback to escalate. The system feeds itself. So one example of positive feedback happens in blood clotting. So when you damage the blood vessel wall, that releases chemicals, and the chemicals attract platelets. And the platelets then release chemicals that attract platelets, which release the chemicals that attract platelets, which release the chemicals that attract platelets, which release the chemicals that attract platelets, until you've quit bleeding. So it escalates. Positive feedback escalates until it solves the problem. You also have positive feedback in the kidneys, which we will talk about next semester when we get there to countercurrent multiplication. You also have positive feedback in labor and delivery, because as the baby drops, that activates stretch receptors further down in the uterus, which causes muscle contractions, smooth muscle contractions in the uterine wall. And those push the baby down, which activates more stretch receptors, which causes contractions, which push the baby down, which activate more stretch receptors. And you don't want to quit in the middle. I mean, okay, you want to quit in the middle of this process. You want to be done, but you don't want to be stuck in the middle of the process either. So it doesn't quit until the baby is born. Just like the blood clotting doesn't quit until you're no longer bleeding out. So positive feedback loop continues to escalate until the situation is resolved. Okay. Disease we already talked about. I was ahead of myself by 5 minutes, which happens. And that's outside of WNL, outside of within normal limits. When you have left homeostasis, you have entered disease. The state of equilibrium are when two opposing forces are in balance. So when your blood sugar is not too high and not too low, when your blood calcium is not too high and not too low, when your temperature is not too high and not too low, this is a state of equilibrium. But each system affects other systems, right? When you the sodium levels affect the chloride levels, which affects other things, which affects the potassium levels. So dynamic equilibrium is when all of your physiological systems are in balance. So a state of equilibrium monitors one system, two forces, one system. And dynamic equilibrium is when all of your systems are in balance, and that is homeostasis. Okay, and now for some end of chapter 1 quizzes. What is anatomy in a word? That's right, structure. What is physiology in a word? Function. Ooh, what was pathology? Do you remember? It's when things go wrong. Yeah, it's what goes wrong. Gross anatomy is what you can see with the naked eye. What's the one word, 50-cent word for gross anatomy? And it's macroanatomy. Did I spell that? It's just like microanatomy, but with an A. Macroanatomy. And what is microanatomy? Right, you need a microscope. Oh, did I tell y'all the microscope story? I didn't tell y'all the microscope story. Okay, my daughter, when, keep in mind my kids have an anatomy teacher for a mother. When she was almost 4, not quite 4, she had these little sisters because she wanted siblings, and I did not provide extra siblings for her. I just have the 2. And she's 11 now, almost 12. 12. They're both December babies, so he'll be 15 in December, and she'll be 12 in December. They're 14 and 11 now. Anyway, so she was 3, almost 4. And for years, she had these little sisters. And one weekend, I accidentally referred to her little sisters as imaginary little sisters. And I got told off, and she told me in no uncertain terms, no, Mama, they're not imaginary. They're microscopic. That's why you can't see them. But in this cute little 3-year-old voice, I was like, okay then. And then she said, they're like motes of dust floating in the air. And I tell her this story now, and she's like, what are motes? But we had just talked about them with, you know, the sunlight comes in the window, and you can see the little bits of dust floating around. Those are motes of dust. Anyway, we had just had that conversation like the day before. So anyway, she's adorable. In fact, she came in here earlier with a fancy, we once had a fancy things, goblet thing, dessert cups, a fancy thing. She had made some pink fluff, and pink fluff is a Cool Whip. Fluff, anything fluff is always Cool Whip. Cool Whip with a can of cranberry sauce with the berries in, because hello, and a can of pineapple tidbits with the juice, about half of it, and marshmallows, the little marshmallows, if you have them, and if you like the hard, chewy, forever, which I don't, coconut, you put the sweetened dried coconut flakes in them, which I hate, but my mother-in-law loves, so it is what it is. Stop. Okay. Anyway, she came in here with this fancy thing of pink fluff, and she was trying to interrupt the video to bring me this fancy thing of pink fluff so that y'all would know how cool she is. But her timing was off, and I was in between videos, so I'm telling you how cool she is. Okay. All right. Okay, so the smallest living units, and there's a different order than we've been saying, the smallest living units are cells. The smallest chemical units are atoms. And that's not atom, A-D-A-M, but A-T-O-M, like atomic. Homeostasis is where you all said the maintenance of a relatively stable internal environment. No? Okay, say it now. Homeostasis is, there you go, the maintenance of a relatively stable internal environment. Oh, I tend to give you the answer and then ask questions, because saying it out loud cements it into your head better than just hearing it. Just like writing things down cements them in your head better than just reading them. So the more you interact with the material, the better you remember it. So hearing and reading are important first steps, but you need to say out loud and also write them down on your own. So if you can draw, that's even better. If you can't draw, there should be some documents called prints in the Where to Find Extra Resources, and those are copyrighted, so please do not share those online. Those are for you as a self-study assignment. Haha, I used the words, so now I'm within copyright regulation. Yay! No one can afford copyright lawyers. So definitely stay within copyright rules. You may use those, you may print them out. I especially like the ones for lab, and my suggestion is to print them out black and white. And if you and then you can color each structure a different color. And then on the back of the same page, put the name of that structure correctly spelled in that color, so that you've just made a giant flashcard. Now, if you can draw and label, that's better. But for those of us who can't draw, I've made the prints, which are the unlabeled JPEGs out of the book, but several editions ago. So they may be a little different than your pictures, but the anatomy is still the anatomy. And for lab, I especially like the idea of putting those prints in a clear plastic sheet protector. You can get like 10 of them for a couple bucks at Walmart or Office, whatever store. There's like 2 of them. I never can remember which is which. Or Staples. Do we have Staples in Corpus? I'm trying to remember where the Staples is, and I'm not. I know where the Staples is in my hometown, but I don't think we have a Staples here. Huh. Anyway. Yeah, I have no idea. Off topic. So if you put that in a clear plastic sheet protector, then you can label those structures with a dry erase marker, check your spelling, wipe it and do it again, because in lab, spelling counts. The lecture test will be largely A, B, C, D, or E, multiple guess, some true false mixed in, maybe some matching, then even the matching will be A, B, C, D, or E, where you choose the best matching answer. So you only have to recognize that answer when you see it, but in lab you have to recall that stuff off the top of your brain. And because it's fill in the blank and we only have the correct spelling typed in for correct answers, you really do need to be spot on that spelling. And we haven't typed in every possible correct answer. We've typed in these. So what we are looking for on the lab test are literally verbatim these terms. So if you've written something that you found on the interwebs that's not what's in this book, then that's not for credit. That's not right. And it's a waste of your time to memorize things that are wrong answers on the test. So this literally, if it's not in this booklet, it's not a right answer on the lab test. So that's how that works. Okay, off topic. So we were talking about homeostasis is the maintenance of a relatively stable internal environment, exactly. And negative feedback is when you negate the stimulus. Whatever's wrong, you do the opposite. Oh, what's a brachium? The brachium is the arm, the brachial region. What's the femoral region? Where the femur is, so the thigh. Remember, not the leg, because that's below the knee. The thigh is from the hip to the knee, and the leg is from the knee to the ankle, just like the arm is from the shoulder to the elbow, and the forearm is from the elbow to the wrist. Upper limb, lower limb. So that's how that works. All right, and did our timer go off? Oh yeah, long ago. Okay, so we covered a page. plus our quiz. So this has been ANP1, Lecture Test 1, video, poop, I had it in my head, video 6, and we covered, this is the end of chapter 1. So we will come back with video 7 and talk about chemistry. As a reminder for chapter 1, there is nothing in the book in chapter 1 that you're not responsible for the test. Chapter 2, there are large chunks that you are not responsible for the test. For chemistry, I have gone through, after teaching ANP1 and ANP2 for several years, I went through it and edited it to just the bits of chemistry that come back up in class, either ANP1 or ANP2. Everything else I've cut out. You are taking chemistry, you can learn those then. I'm only teaching the part that I feel is relevant for anatomy as we are learning it in this class. And then chapter 3, we're learning most of it, but not all, like the microtubules. We're not learning like the 9+0 or any of that. So definitely keep track of the note set. Read the book, but read the book as listed in the note set. So, all right. Happy to see y'all here virtually. And thank you, as always, for tuning in. The education must go on. Dr. J out.